Lesson 11, Algebra 2, the special role of 0 in factoring. So the idea is that we can factor, right? We can solve a polynomial equation by factoring. In your Algebra 1 class, you learned how to factor quadratics and how to solve quadratic equations, right? Remember, you would use the you could use the quadratic formula. You probably even learned completing the squares. Today we're going to focus on solving them by factoring, and we'll have a few quadratics that we'll solve by factoring. We'll get this thing done. So we're going to have a little refresher on factoring. I'm going to show you something that maybe you've never seen before, a new method for factoring. So let's get down to it. So I have x squared plus 5x plus 6. Remember, when we're factoring, we're going to wind up with some the product of some binomials, right? So it's going to look like this, where this binomial, right, is going to be that polynomial, right, and then this one would wind up being this polynomial. So let's factor this. So I need to factor x squared plus 5x plus 6, and I need to factor x squared minus 3x minus 4. Let's do it. All right, so first let's factor x squared plus 5x plus 6. All right, so you can go about this two different ways. All right, there's actually like a method that you can use that this is the way I usually teach it. I use a method called the X box method. It's pretty neat. Works every time for every single quadratic that can be factored. The other way you could go about it is this is what you'll do when you get faster. This is just think of two numbers such that when I multiply them, I get when I multiply them, I get positive 6, and when I add them, I get positive 5. There's actually a little tool that you can use if you want to that helps you remember that, and that is this x, right? So on the top of the x, I put my c value, and on the bottom of the x, I put my c value. Right, because we remember that quadratics are always in the form ax squared plus bx plus c. So when I say it's my c value, I'm talking to that constant. All right, in the side, I'll put these two numbers that would multiply to 6 and add to 5. Now, if I'm thinking about that, I think of factors of 6, right? So the factors of 6 are 1, 6, 2, and 3, right? Those are all of the numbers that divide 6. Well, I heard 2 and 3 in there, and that is perfect, right? 2 times 3 is 6, and 2 times 3, 2 plus 3 is 5, right? Fantastic, right? Now, at this point in time, you've found the numbers, but there's also another piece that goes with it. You don't usually have to do this piece, but I want to show you a couple of times how to do the box portion of it. And the reason why you would normally use this box portion is when the coefficient of x is not 1. So here, the coefficient of x is 1, right? So I could just say, hey, it's got to be 2 and 3, and it's factored, right? But if it wasn't the case that the coefficient of x squared was 1, I would have to do a little more work. And doing like a guess and check is pretty challenging. We'll do a harder one as we go. But I want to show you how to use this box. But the way it works is my x squared goes there, right? So I'm putting this term there. My c term is going here. And then I'm going to take, and it doesn't matter which one, I can put the 2 here and the 3 here, or vice versa, it doesn't matter. But I got to give them an x, right? And the 2 that I'm talking about, right, is this 2, and the 3 I'm talking about is that 3. I'm going to find the greatest common factor of my rows and my columns. The greatest common factor here is x. The greatest common factor is these 2, right, because x divides both of them. The greatest common factor of these 2 is 2. The greatest common factor here is x. And this one is 3. And there it is. There's my x plus 2 and my x plus 3. It's the Xbox method for factoring. Works seriously every time. Once you get into higher mathematics, you'll be able to just kind of figure these out. But for now, it's a nice to have a tool. Okay, so that means that over here we have x plus 2 and 3 minus 2. Now, I'm not going to use the Xbox method to factor this next one. I'll normally stick with using that method if the coefficient of x is not 1. Otherwise, you can just set it up like this and say, okay, I've got to take this x squared minus 3x minus 4 and factor it into the product of 2 binomials by thinking to myself, hey, what are 2 numbers such that if I multiply them, I get -4, but if I add them, I get -3? Well, let's think of factors of 4. Factors of 4 are 1, 4, 2, and 2. That's it, right? Those are the only numbers that evenly divide 4. So 2 and 2 is not going to work. There's no way I can add 2 and 2 and get 3, right? So I got to have a 4 and a 1, right? And think about this. If I'm going to FOIL this thing out, right? Because I have to decide where a plus and minus sign goes. I got to have a minus sign because I've got a minus sign here, right? So my 4 times my 1, 1's got to be negative in order for my 4 in here to be negative, right? Again, I'm imagining that I'm actually FOILing this thing out, right? This one goes there, and that one multiplying times that one, right? So how, and that's how I'm imagining that I will place my sign. Well, if I want the 3 to be negative, that's got to be negative, and that's got to be positive, right? So that's the process that I use if I'm not going to use the Xbox method. So let's answer the question. Let's find all solutions. So we've set this thing equal to 0. So that means that any value of x that I could plug in there that would give me 0 would be a solution, right? So for instance, imagine that x is -2. If I plug a -2 plus 2 in here, right, I get 0. And then isn't it true that this 0 has to multiply all of these things? Which would give me 0. So when I plug -2 in there, I get a true statement saying 0 equals 0. And any value of x that we could plug in there that would give that true statement 0 equals 0 is the solution. That's why it's also called 0, the 0 of it, right? The solution to this equation is also called the 0. So let's look at what our zeros are. Well, because of this one, I said we have x equals -2. This one gives me x equals 3. This one, x equals 4. And this one, x equals -1. And why again? Because you can check it. If I plug each one of those in there, I get 0. Okay. We did it. Those are the solutions. We finished. This particular equation has 4 solutions. Okay. Okay, let's find the solutions of x squared minus 9 times x squared minus. With this one, you guys probably learned this as well in Algebra 1. There is a general formula called difference of squares. I got a general formula for this property called difference of squares. It turns out that a squared minus b squared is equal to a minus b times a plus b every single time. All the time. Every time. All right. So in this case, if we look at this one, right? For x squared minus 9, we would say that a is x, right? And in this case, b is 3, right? Right? So that's 9 is 3 squared. So it's like I have x squared minus 3 squared. So then I can factor this piece as x minus 3, x plus 3. And then the x squared minus 16, my b in that case is 4, right? So this becomes x minus 4, x plus 4. And there we go. We've got it completely factored. And now we can find a solution. You don't have to use difference of squares. Also, if you wanted to factor this, you could think, hey, for instance, for looking at the x squared minus 9, I could think, hey, what are two numbers that multiply to negative 9 but add to 0? So that's the other way to look. Well, it would be negative 3 and positive 3, right? If you add negative 3 plus 3, you get 0, and if you multiply, you get negative 9. So that's another way to approach it. You don't necessarily have to use difference of squares on these. You could also factor them in that way as well. You could use the Xbox on them too, if you do that and you really like it. Okay, but let's get down to the heart of the matter. X is going to be 3 because of this one, right? I'll also have x equals negative 3, x equals 4, and x equals negative 4. There we go. We've got solution. All right. Example 1. Feel like we did lots, but here's example 1. If we know this polynomial there has 3 real solutions, and that one of the factors is x minus 1, in other words, right, x minus 1 divides 4x cubed minus 12x squared plus 3x plus 5 evenly, then we can find all 3 solutions. Clearly, if x minus 1 is a factor, one of our solutions is going to be positive 1, right? We got to find the other 2. How are we going to do it? We'll use division. And I'm going to use synthetic division because I don't like to do extra work if I don't have to. It's not called being lazy, it's called being efficient. Here we go. 1 times 4 is 4. Negative 12 plus 4 is negative 8. 1 times negative 8 is negative 8. 3 minus 8, or 3 plus negative 8 is negative 5. And 1 times negative 5 is negative 5. And 0, and that's fantastic, right? We need to have a 0 remainder if it is indeed a factor. So that means that when I when I divide that, I get 4x squared minus 8x minus 5. What does that mean? That means that I can write this in this way. I can say that that 4x cubed minus 12x squared plus 3x plus 5 is equal to x minus 1 times 4x squared minus 8x minus 5. Those two things are the same, right? And check it out. I mean, if you were to divide both sides by x minus 1, you would wind up with a true statement, right? We said that when we divide that polynomial by x minus 1, we get 4x squared minus 8x minus 5. Perfect. So I'm going to go ahead and put this back into our equation here. We're going to say, or this equation. So we have 4x cubed. We have x minus 1 times 4x squared minus 8x minus 5 equals 0, right? That's the same as that, right? I've just divided. So now I suspect if there are 3 solutions, I suspect that I should be able to factor 4x squared minus 8x minus 5 in such a way that I wind up with some binomial, right? Some product of 2 binomials. That means I got to factor it. And that's kind of nasty, right? It is. Because you could sit in here and guess and check all day, right? You could try to put a 4 here and a 4x here and and an x here, right? And then try to see if it works. It's just going to take a long time. So I'm going to show you how to do this with the Xbox method. Unless you can see it, sometimes people are able to really think ahead and think about a lot of things at the same time. And we can get there. But it gets tricky. This is going to work every single time. Let's go Xbox method. So in other words, I want to make this look like that, all right? So I'm going to get out my Xbox. So up here, this is A times C in this case, right? In other words, I need to multiply 4 times negative 5, and that's going to go there, all right? That top box is always the product of A times C. The bottom box is B. Right? Remember, because I was saying that these are in the form ax squared plus bx plus c. Right? That's why I'm getting those A, C's, and B's from. All right. So now, just the same as I was doing before, I need to think of 2 numbers such that when I multiply them, I get negative 20, and when I add them, I get negative 8. So I got to think of factors of 20, right? We got 1 and 20. 2 and 10, I can definitely combine a 2 and a 10 to get an 8, right? I'll just have to make one of them positive and one of them negative. So if my 10 is negative and my 2 is positive, that works perfectly. So now it's time to get the box out. And it's always going to be a 2 by 2 box if you're using the Xbox method 2-factor. In here is going to go my first term. My last term goes here. And then my 2 terms from my box, or from my X, go over yonder. And I could switch them. It doesn't matter. I can put the negative 10 where the 2x, negative 10x where the 2x is, and vice versa. And it won't change my answer. But I always have to have the first term in my upper left-hand box, and I have to have the last term in my lower right-hand box. So now I need to find the greatest common factors of my columns and my rows. The greatest common factor of these two is 2x, right? 2x divides 4x squared. And 2x also divides 2x, right? The greatest common factor of these two is going to be negative 5. right? It's not x because there's no x over here with this negative 5, so it's got to be just a number. These two both share an x in common, so definitely they'll be both divisible by x. And the greatest common factor of 4 and negative 10, we'll call it 2x. There we go. And this one is 1. Right? Greatest common factor of 2x and negative 5 is 1, right? Greatest common factor, I'm saying the largest quantity that divides both of them. So that means that this factors as 2x plus 1, 2x times 2x minus 5. Awesome. We did it. And if you are not sure, you can always check these. They're so awesome because we've just done kind of the opposite of multiplication. So you can FOIL this thing out and see that indeed 4x squared minus 8x minus 5 is equal to the quantity 2x plus 1 times the quantity 2x minus 5. Yay, let's put that into our problem now. So this is 2x plus 1, and this is 2x minus 5. We did it. It's factored. We factored that big thing. All right, now let's go ahead and find our solutions. This one's the easy one, right? X equals 1, right, because of that. But these are a little different, right? I can't just put in the opposite sign. What I have to do is actually solve a little linear equation, right? So what I need to say, what I want to know is, hey, what value of x do I put in here to get that whole thing to be 0? There's another way to express that. I can use a linear equation to say that. And say, hey, 2 times some number plus 1 is 0. And I can solve that, right? I'm going to subtract 1 from both sides. I wind up with 2x equals negative 1, and then I divide 2. Right, I divide both sides by 2. Those cancel out because it's 1. And I get x equals negative 1/2. So there's our second solution. We'll do the same thing with this one. 2x minus 5 equals 0. So we'll set it equal to 0. Or let it equal 0. You can say that as well. I'll add 5 to both sides. And then divide both sides by 2. And there is our third and final solution. So our solutions are x equals 5/2, x equals negative 1/2, and x equals 1. So that is how we can find all 3 solutions to that given equation. Okay. So we're going to find the zeros of these polynomial functions with their multiplicities. And we'll talk about the definition of multiplicities. I guess I'll talk about it right now. This is the number of I should say the amount of a particular zero. The number of a given, the amount of a given zero, I apologize. The amount of a given given 0 that occurs in a factor polynomial. And we'll get down to that. We'll talk about multiplicity. It's actually super easy. Super easy. Nothing really too bad. I'll show you. So for this one, let's find the zeros. Obviously, x equals -1, right? From the first one. Also, x equals 1. For this one, for the x squared plus 1, I'm going to have to solve that, right? I want to know what number can I plug in for x that would give me 0 there. And I'm going to solve it, so I'll subtract 1 from both sides. And then you remember from way back in the day when you learned the Pythagorean theorem and you had to solve for like a missing side of a right triangle, you would have to square root both sides. The square root of x squared is x. And remember, when you square root both sides, you need to consider positive and negative values. So I get that the answer is x equals plus or minus the square root of -1. Now, if you put that into your calculator is going to shout at you. It will not give you a number answer. It will shout at you, that's not real. And that's true. It's true. We'll deal with this later. There's a clever way that we can deal with something like this, but in this case, we're going to say this is a non-real solution, and we're not going to count it for right now. Right now, we're going to only look for real solutions, so these are them. Anything else you would just want to call a non-real solution? All right, so let's look at this next one. Clearly, the 0 here is x equals 4, and then our next one we have is x equals 2. But let's talk about the multiplicity. This is it. This is all we got to do. I just got to look at this number right here to get my multiplicity. So if I was to ask for the multiplicity, I would say, hey, the solution is x equals 4, and the multiplicity is 3. Our other solution, which I'm running out of room for, let me make a little partition here so that they don't bleed together too much, is x equals 2, and that has a multiplicity of 8. Here it is right there, 8. It's that simple, not that bad. All right, let's do the next one. Okay. First of all, let's figure out what our 0 is. I got to solve 2x minus 3 equals 0. So, and I'm just going to make the jump and tell you that's 3 halves. All right, I added 3 to both sides, and then divided both sides by 2, and I got 3 halves. And what is my multiplicity? It's 5. Yay! All right. Over here, let's name my zeros. The first one, I got to solve 3x plus 4 equals 0, which turns out to mean that x is -4/3. And my multiplicity is 100. My next solution is x equals 17. Multiplicity 4. Here we go. And here's the last one that we're going to do for this lesson. We're going to find a polynomial function that has the following zeros and multiplicities. So I can find a binomial that satisfies this, right? If I had x minus 2 here, right? A 0, the 2 is definitely a 0 of x minus 2, because if I plug 2 in here, I get 0. And my multiplicity is 3, so I put that way. Over here, if my 0 is 4, then I would have to put x plus 4, right? Because if I plug negative 4 in there, I get 0. My multiplicity is 1. I don't have to put a 1 there. I could. It wouldn't be wrong for me to put a 1 there. But it's assumed that that's actually already there. Let's look at this one. My 0 is positive 6, so I'll want x minus 6 here. Multiplicity is 6. And then for this guy, x plus 8, my multiplicity is 10. So the polynomial that I would put in there, is going to be x minus 2 cubed times x minus 6 to the 6th times x plus 4 times x plus 8 to the 10th. So there's my polynomial that has zeros of 2, negative 4, 6, and negative 8, right? And that has those given multiplicities. How would we find the degree of this polynomial? We could really just add up those exponents. Just think about it. Think about it. Real quick. What's the multiplicity of this? If I multiply it out, I wind up with an x squared, right? So if I had another one, I would wind up with an x cubed, right? So if I added on an x plus 1 to this, I would wind up with an x cubed, right? Because I would have an x times x times x. So it makes sense that I could just add up all of these exponents, right? So 6 plus 10 plus 1 plus 3. So my degree should be and that's how you can do it every time. Just add up if you have a polynomial in factored form, and you can see these different multiplicities of each one of those binomials. You just add up those exponents, okay? All right, we are not going to do the rest of it. So that's all. Thanks so much. Thanks for watching. I hope you have a wonderful evening, and we'll see you tomorrow.